7-1, the law of sines, day 1. So we've been working with triangles that have right angles, but now the law of sines is used to solve oblique triangles. That means either they're going to have 3 acute angles smaller than 90, or 2 acute angles and 1 obtuse angle. The key thing to remember is there are no right angles in these triangles, so you can't use Pythagorean theorem. So basically, the law of sines is a ratio between the angles, you have to use sine of the angle, and the opposite side. And you can use any of these ratios to help you find the missing side or the missing angle. You can set it up where the angle is on top, or you can set it up so the sides are on top and the angles are in the denominator. And usually when you're solving these, you are cross multiplying. And you can use any 2 ratios to solve the triangle. So one of the triangles that we can use the law of sines is with a side angle. And so when you draw it out, this means that they give you one side, which is a little c, and the angle across from it. And then they give you another angle. And then they ask you to solve it. That means you're going to find angle B, and little a. So the first thing I do when we have a side angle is find the third angle. So I would add 46 and 63, which is 109. Then I'll take that and subtract it from 180. And that means angle B is 71 degrees. Okay, so I've taken care of my third angle. Then I use my law of sines to help me find the other 2 sides. Now, it's very important that you use the side and the angle that was given. So I'm going to use sine 63 degrees over little c, because that's what's given. So try to keep using this ratio. And then you pick which side you want to solve for next. So I'll just do A equals sine 46 over little a. So the angle and the side have to be opposite each other. And then I just cross multiply. Make sure your calculator is in degree mode. So you're going to do sine 63 degrees times A equals sine 46 degrees times 56. Get A by itself. And you should get approximately 45.2 inches. And then you do the same thing to find little b. I'm going to use the c again, sine 63 degrees. And the reason why is so that you know that this was given, so you're less likely to make a mistake. Remember, angle B was 71. And you just cross multiply again. So sine 63 degrees times B equals sine 71 degrees times 56. Divide to get B by itself. And then for a little b, you should get approximately 59.4 inches. So there, the triangle is solved. So in example 2, another triangle that we can use the law of sines is if they give us an angle, a side, and an angle. So let's say they gave us angle A was 50 degrees, angle C is 33.5, and then little b is 76. And it doesn't matter how you label your triangle. So we have angle A, then we have side B, and then angle C. So see how the side is in between the two angles? That's the angle, side angle. So the first thing I do with this triangle, again, I find my third angle first. So I add 50 and 33.5, and I get 83.5, and I take that and I subtract it from 180. So angle B is 96.5 degrees. So now I have all three angles. Now I can find little c or little a. So now I'm going to use B's information as my base. So I'm going to use this ratio to help me find either little a or little c. So let's go with a again. So you're going to do sine 50 over little a. And then you cross multiply again. Sine 96.5 times a equals sine 50 times 76. Then you divide to get a by itself. And then you should get little a is equal to 58.6. Then you do the same thing to help you find little c. So I'm going to use B's information again because you're less likely to make a mistake. Sine 33.5 degrees over little c. And then you cross multiply. Using the same steps as before. And then divide to get c by itself. So little c should equal approximately 42.2.